It's important to realize that when you're talking about motion, it's relative to what your frame of reference is. For example, what is your current speed sitting there in front of your computer? Well, all three of these are correct. Relative to the floor, your speed is 0 meters per second because you're not moving compared to the floor. Relative to the sun, your speed is 30,000 meters per second. That's the speed the Earth is rotating around the sun. And relative to the center of the universe, your speed is more than 50,000 meters per second because that's the speed at which the Earth is moving away from the center as the universe expands. So you can see that depending on what your frame of reference is, your speed is different. Let's talk about an example. If you are running in a race, the other guy is running 6.5 meters per second, and you're running 6 meters per second. To the people sitting in the stands, it looks like you guys are moving very fast. But if you've ever been running in a race, you might have remembered that the other runners didn't seem to be moving that fast from your perspective. And that's because in this situation, relative to you, the other guy's only running half a meter per second, which is why he doesn't look nearly as fast to you as he does to the people sitting in the stands. Let's talk about another example. A school bus is moving at 10 meters per second, and students are playing ball on the bus. A student at the back of the bus throws the ball to the front at 3 meters per second. To all the other students on the bus, that ball seems to be going 3 meters per second. But to somebody sitting on the sidewalk, that ball looks like it's going 13 meters per second because it has the speed of the bus, 10, plus the speed of the throw, 3. But then the student throws the ball back to the student in the back at 2 meters per second. Again, to all the students on the bus, it appears to be moving 2 meters per second. To the person on the sidewalk, it now looks like it's moving 8 meters per second because this bus is moving forward, and we'll say that's positive 10 meters per second, and the ball is moving backwards at 2, so negative 2 meters per second. So 10 minus 2 gives us 8 meters per second. Sometimes this relative velocity doesn't work. So we have this high-speed train, and it's moving at 400,000 meters per second. A light moves at 300 million meters per second. So that headlight on the front of the train, the light coming out of it, should be moving 300,400,000 meters per second. But it doesn't. Einstein's theory of special relativity says that nothing can move faster than the speed of light. In fact, when things start approaching the speed of light, weird things start happening to them. So our relative velocity, So relative motion breaks down whenever we're talking about objects moving at or close to the speed of light.